Hi, this is Dr. Praveen Kumar Kaushik and I welcome you all in Om learning classes. So in this lecture we have discussion about power content in VSB-SC signal. So as per the power content in DSBSC and SSBSC, we have the similar phenomena in VSBSC. Here we utilize the general representation of signal power, which is the ratio of the square of RMS value of signal voltage to the load resistance value. And further, the RMS value of signal voltage is defined as the ratio of peak value of signal voltage to the square root 2. And by utilizing this mathematical formula, we have the modulating signal power corresponding to our modulating signal, which is AM cos 2 pi FMT, and that is equivalent to AM square by 2 into RL. Similarly, we have the carrier signal power, which is equivalent to AC square to 2 into RL, corresponding to our carrier signal, that is equivalent to AC cos 2 pi FCT. And as per the representation of VSBSC signal, we have the USB modulated wave, that is equivalent to 1 by 2 into AC into AM into cos 2 pi bracket start FC plus FM bracket close into T plus F into bracket start 1 by 2 into AM into AC cos 2 pi bracket start FC minus FM bracket close into T finally bracket close. And this F represent the fraction value of undesired sideband, and this fraction value is corresponding to vestige portion of this sideband, and that will give the gradual cutoff in their graphical representation. By utilizing this modulated VSBSC wave, we have sideband signal power, which is corresponding to both sideband. So we get the total sideband signal power, that is equivalent to P USB power of USB plus fraction value of power of LSB sideband. And here if we take the P USB, that is equivalent to AM square into AC square to 8 into RL. And we have the LSB power, which is equivalent to AM square into AC square to 8 RL. By utilizing the total sideband signal power for VSBSC wave, we have the P USB plus fraction value of P LSB, and we get that is equivalent to AM square into AC square to 8 into RL plus fraction value of AM square into AC square to 8 RL, and which is further equivalent to AM square by 4 into PC plus fraction value of AM square to 4 into PC, and where the PC is carrier power, which is equivalent to AC squared by 2 into RL. And if we have the multi-tone signal, then the total sideband power is equivalent to sum of all value of upper sideband power and the fraction of sum of all of lower sideband power. And similar to DSBSC and SSBSC, we have the modulation and transmission efficiency, which is the percentage of total power contributed by the sideband, as the sideband contains the transmitted information only. So we have the modulation and transmission efficiencies for VSBSC, and that is equivalent to total sideband signal power to the total modulated signal power. And for percentage, we have the multiplication of 100. And if we calculate this, then we have the modulation and transmission efficiency which is equivalent to 100%, similar to DSBSC and SSBSC. As the carrier power is absent, only sideband power are transmitted as modulated wave for VSBSC signal. So if we conclude this power content, then we have the conclusion that the power and the bandwidth requirement of VSBSC modulation scheme is slightly large than SSBSC, but it is less than DSBSC. So VSBSC have the important advantage of power and bandwidth requirement over DSBSC, and it have the important advantage of filter design over SSBSC that have no requirement of sharp cut of band pass filter at the transmitter site, which is corresponding disadvantage of SSBSC. So this is all about the power content of VSBSC signal, which is very important because we calculate the power content of DSB full carrier or AM. We calculate the power of SSBSC. We calculate the power of DSBSC. Then it is also requirement to have the power calculation about VSBSC signal. So with this, we complete this topic. So thank you very much for your precious time. Stay healthy and enjoy smart learning. And please subscribe this channel for getting regular updates. Thank you very much.